Hello, we are the Motion Capture Project Group for Sign Language Education. As a background, Sign Language is the second official language since 2016 in South Korea. And there was also license of sign language since 1997, and from 2005 each promoted to national license with the needs of expertise. As you can see the graph on the right side, the deficit of manpower in the fields are main problem. There are more than 200,000 of hearing impaired people. On the contrary, there are only about 800 sign language interpreters. That's why there's urgent needs of people who can use sign language, especially at hospital, police office, bank, etc. So we tried to make some educational tools with application for sign language. First of all, we sketched our ideas to visualize the details. After that, we tried to design several main functions to take shape of application. Finally, we managed to develop prototype with functional implementation.
Now we will explain process of technical implementation. We first tried hand recognition through the OpenCV library. OpenCV is library that we will list to use when image processing is in place. OpenCV recognizes the tip of finger and predicts the shape of the hand. However, we couldn't get skeleton of hand and capture of body movement because it only predicts the shape of our hands. So it gave us inaccurate motion capture. Then we decided to recognize motion by OpenPose. OpenPose is API that tracks body movement including hands and face. It captures all the body skeleton and shows us 2D image from the captured body in real time. So we could get accurate sign motion capture and apply sign language movement recognition to the app. If you do sign language motion in front of a camera, our app captures your movements through OpenPose.
I'm going to explain how our app can be used through a potential scenario. We took two users. First is an user who have contact with deaf people. A second user is who want to take prior learning. Let me explain first user scenario first. This user want to know sign language that corresponds with Korean words because they lack knowledge of sign language. For this, our app provides word finding function. Furthermore, sometimes communication requires more than words, so learning for communication or helping through experts could be provided by our app. Next user is who want to learn basic sign language. For this user, the factors of interest may be important. Our app provides sign language learning categories so that they can learn what they are interested in. Additionally, the user have few opportunities to use sign language. Then he or she can have ambiguity whether learning is going well. Thus, our app provides learning achievement feature, also provides sign language games, so the user can use sign language they learned.
Let me explain the technical process for motion recognition. Many errors occurred during motion recognition when initially deploying motion recognition with CPU. The cause of the error was due to a large number of video data that needs to be processed for motion recognition. So, we finally implement the technology through GPU, which specializes in graphic processing. GPU also being changed use CUDA for various applications as well as graphic processing. And for motion recognition, we need to able to use artificial intelligence to recognition model. So we use cuDNN. which enables GPU to optimize artificial intelligence. But CUDA and cuDNN don't work in Windows. So we built a new environmental use of build program called CMake to fit the window. We use window PowerShells to utilize the location values of the data and two types of function requirements for motion recognition called Body25 and Coco. Finally, our team chosen Body25 and used it to build motion recognition technology. Body25 is expressed as a skeleton suitable all in areas where facial and body movement occur. This shows that the body shape of the bone varies depending on the area of mouth, jawline, and finger joints. It also receives human movement in real time, and change in the bone appear on the screen. It can even show microscope movements such as eyebrow. The advantage of these two are that when using sign languages, there can be variety of situations, such as reading out the shape of the mouth. Use the fingers, which I thought would be good technology to cover all situations.
아, 어. 깨끗하다. 보다.
We conducted user tests on a total of 7 people. 5 of them tested non-face-to-face. We got user feedback after using the app prototype by the users or showing the app demonstration. Users have given positive feedback that the app will be useful for sign language training. Through motion recognition, the purpose of sign language education can be effectively achieved. This is all for our presentation. Thank you for all your attention.